simplest kind of motion an object can experience is uniform motion in a straight line. The following are examples of linear motion. How can we say that an object moves? We say that an object moves if the object changes its position. To locate an object means to find its position relative to some reference point, often the origin. A vector that points from an object's initial position to its final position and has a magnitude that equals the shortest distance between two positions is called displacement. The SI unit of displacement is meter. If you drive from your house to the grocery store and then to your friend's house, what is your total distance? What is your displacement? One of the most obvious features of an object in motion is how fast it is moving. If the object covers the same distances in each successive unit of time, it is said to move with constant speed. Average speed is equivalent to distance traveled over time elapsed, while average velocity is equivalent to displacement over time interval. If the runner sprints 50 meters in 8 seconds, what is his average speed, his average velocity? If he walks back to the starting point in 40 seconds, what is his average speed, his average velocity? One method of describing the motion of an object is to plot its position x as a function of time t. The average velocity is the displacement divided by the time interval for the displacement. The instantaneous velocity is obtained in the limit that the time interval for the averaging procedure approaches zero. When a particle's velocity changes, the particle is said to undergo acceleration. The average acceleration is defined as the velocity change per time interval. The instantaneous acceleration is given by the following formula. An object is moving along a straight line in the positive x direction. The graph shows its position from the starting point as a function of time. Various segments of the graph are identified by the letters A, B, C, and D. Questions. Number 1. What is the velocity in segment A? Number 2. What is the instantaneous velocity at the end of 8 seconds? Number 3. During which intervals did the object move backwards? Applications. A motorist is speeding along at 100 kilometers per hour when he sees a squirrel on the road 200 meters in front of him. He tries to stop, but it takes 12 seconds for his car to stop. A. What is the acceleration of the car? Assume acceleration was constant. B. Does the squirrel survive? C. How fast was the car moving at 100 meters? Solution. Using equation 1, velocity equals initial velocity plus acceleration multiplied by time, where velocity equals 0. Plugging in the values, 0 equals 27.8 meters per second plus acceleration multiplied by 12 seconds. We'll then have acceleration equals negative 2.32 meters per second squared. Note the acceleration is negative. This means the vehicle is slowing down as motion progresses in the positive direction. Just what you would expect in a problem where the vehicle is slowing down. Using equation 3, velocity squared equals initial velocity squared plus 2 times acceleration times displacement, where velocity equals 0. we have displacement equals velocity squared minus initial velocity over 2 times acceleration equals 0 minus 27.8 meters per second squared over 2 negative 2.32 meters per second squared equals 167 meters. The distance the vehicle took to stop was less than 200 meters, so the squirrel did survive the encounter. Using equation 3, velocity squared equals initial velocity squared plus 2 times acceleration times displacement, where displacement equals final position x minus initial position x. Plugging in the values, we have velocity squared equals 27.8 meters per second squared plus 2 times negative 2.32 meters per second squared multiplied by 100 meters. The vehicle was moving at 17.6 meters per second at the 100 meter mark.